It is my pleasure to welcome you to the third part of the crash course, Foundations of Quantitative Research. In this lecture, we're dealing with the quality criteria of quantitative research. First, I would like to give you an overview of the quality criteria, and then I would like to dive in a bit more deeper into reliability and validity. First, the overview. On a general level, there are three classic quality criteria. That is objectivity, reliability, and validity. Objectivity is given when a measurement is independent from the researcher who conducts this research. So if I do the research, you do it, a third person does it, it doesn't matter. We're all coming to the same results. The researcher did not influence the measurement of this project. Reliability asks if the measurement was precise. So, did I measure precisely? You can also think of this, you're coming consistently to the same results. As we have repeated measurements and all produce the same or similar results, happy days, we have a reliable measurement instrument. Validity deals with the accuracy of a measurement instrument in the sense that the measurement instrument measured what it intends to measure. Did I actually measure what I wanted to measure? That is validity. Here with an analogy, I want to exemplify reliability and validity. Think of you want to test a rifle and you have the shot pattern on the left-hand side. So your enemy would be very happy. Of course, your shots are all over the place. They're not in the intended target. So they're not reliable, they're all over the place, and your rifle is not reliable, and therewith it cannot be valid. The second shot pattern in the middle has a very reliable rifle, but unfortunately is not valid. So all your shots go on the right side of your target. They're all at the same spot, but you did not hit your target. So it's a reliable rifle, but you did not hit what you intended to hit. Therefore, it's not valid. On the right-hand side, happy days. You have a reliable and valid rifle. Every shot is on target and no shot goes south, north, east, west. Happy days, reliable and valid rifle. You shot precisely and you shot where you hit where you wanted to hit, where you intended to hit. Now let's go deeper into reliability. As I said, reliability deals with the precision or consistency of a measurement. That means if we were to measure repeatedly, we must come to similar results. And you have different methods to test reliability: test, retest reliability, split half test, and Cronbach's alpha. At this point, in a normal applied research project, you would not do it. Normally, you would not do a test, retest reliability and not a split half test reliability. Quite often, what you need to do is applying Cronbach's alpha. But here, let's go to the test, retest reliability. The idea is, I measure repeatedly, I come to similar results, happy days, high degree of reliability. So the principle you can see on the bottom right. Let's assume we measure something, a construct in January, get our results out, measure the same construct in February, get our results out, compare these results. You normally do it with a correlation analysis, which I will introduce in the last part, the last lecture of this crash course. At this point, correlation analysis shows you how strong two variables are associated. And you can say, if there's a high correlation, I have similar results, to simplify. So we have a high correlation or strong correlation, similar results. Happy days. That means our reliability is good. Let's go to split half-test reliability and Cronbach's alpha. Both split half-test and Cronbach's alpha you can only apply when you have multi-item measurements, and these measurements are reflective measurements. That means multiple items measure one construct, and the construct is reflected by these items. Like you're looking in the mirror in the morning, then the mirror reflects the image of you. Perhaps to make this clear, I have an example on the bottom right here. With this measurement instrument, amongst others, it was a normative organizational commitment was measured. It was measured through 4 items, 4 statements, and the participants had to agree or disagree with these items on a scale from 1, do not agree at all, to 6, agree in full. So with 4 items, and reflective measures, I believe, become clear what this is when you look at the first and the third item. The first item states it would not be fair to terminate the relationship with my employer because my employer steadily supported me. And then, how much do I agree with this statement? The third item states, in the relationship with my employer, I feel obliged to fairness. And you can see, content-wise, they're very similar. They're basically measuring the same. In other words, both are reflecting normative organizational commitment. When you have such reflective multi-item measurements, you can apply, I should say you could apply the split half test. What you do here, you take the first half of the items and the second half and calculate the results for both of them. Again, here, assuming we have 4 items, we have the results for items 1 and 2, and we have the results for items 3 and 4. And then again, we check, are these results similar? Correlate them, and if the correlation is strong, similar results, happy days, reliability is good. The split half test I only introduced here to have the foundation for Cronbach's alpha, which is much more important. Cronbach's alpha works after the same principle of a split half test. But it does not take only 2 halves. Cronbach's alpha calculates the inter-item correlation of all the items of one construct. So what you have here is correlation of item 1 with 2, 3, 4, correlation of item 1, 2 with 3, 4, correlation of item 1, 2, 3 with 4, and all the combinations that are possible. And then out of these correlations, all of these correlation coefficients, Cronbach's alpha is calculated, which is the average, the arithmetic mean of all of these correlations. And Cronbach's alpha can have values between 0 and 1. The closer Cronbach's alpha is to 1, the higher the reliability. And here you can see in our project, the project of me and 2 co-authors, Cronbach's alpha for normative organization commitment was 0.82. It's close enough to 1. Happy days, we can assume we measured normative organizational commitment reliably. Let's head to validity. Validity, as I said before, is the accuracy of a measurement with regard to its theoretical constructs. And I think it is easier to remember, did I measure what I intended to measure, what I wanted to measure? If I did, happy days, I have a high degree of validity. If I did not, very unhappy days, no validity or low degree of validity. There are different types of validity. Construct validity with content and criterion validity. Then we have internal, external validity, and statistical validity. I need to mention here that other scholars have also additional types of validity, like convergence validity, discriminant validity, and other scholars categorize these form types of validities partly differently, in parts, some of them categorize them differently. I, however, think that this structure of types of validity is the best, and I will explain this and go into detail. So what is construct validity? You have a high degree of construct validity if your measurement instrument represents the theoretical construct, or in other words, is the definition, theoretical definition of my construct represented in my measurement instrument. You can distinguish between content and criterion validity. Content validity refers to the adequacy of a measurement instrument to comprehensively and precisely represent a theoretical construct. Here, you use logic and expertise to determine if your measurement has a high degree of content validity. So you look at the content, and through logic and expertise you say, yes, my theoretical construct that I've defined is represented in this measurement instrument. Criterion validity uses, to determining validity, uses an external criterion, that is another construct. And here the definition is, criterion validity represents the adequacy of a measurement instrument to represent a theoretically and empirically established relationship with an external criterion. I will give you examples for both. Here, I would like you to have an overview. So what we're doing here, we're measuring our construct that we want to validate. And we're measuring an external criterion. It's another construct which we use to validate our construct. Then we analyze the relationship between our construct that we want to validate and the other construct, the external criterion. Normally you can use a correlation or regression analysis for this. And then we compare the empirical relationship that we found through our measurement and analysis between our construct and the criterion with the respective relationship that is established in theory and through previous research. As I said, that might be a bit theoretical and on a very abstract level. I hope the examples that I'm giving you now will make this clear. So first, content validity. So logical expertise, logic or expertise we're using to determine the adequacy of a measurement instrument to comprehensively and precisely represent a theoretical construct. Here is an example. Assume we want to measure brand satisfaction. How satisfied is a customer with a brand? On the one hand, we ask, how likely is it that you recommend brand X to others on a scale from 1 not likely at all to 6 very likely? Just using logic, even here common sense, that is not valid. What we are here measuring is actually the probability of recommendation, of brand recommendation. We're not measuring satisfaction. On the other hand, if our question was, how satisfied are you with brand X, on a scale from 1 not satisfied at all to 6 completely satisfied, you can say happy days. That makes sense. We want to measure brand satisfaction, and we directly ask, how satisfied are you? Happy days, content validity, we're golden. Now, criterion validity. So we use an external criterion, another construct, to look if a relationship between our construct we want to validate, if we can find a relationship between our construct we want to validate with the external criterion. And this relationship is well established in the academic in the research literature. The example on the bottom hopefully makes this clear. We know from other research that brand satisfaction has a positive impact on the probability to recommend this brand. So we're measuring brand satisfaction and the recommendation probability. Well, that is what we assume, and we measure this. Brand satisfaction we measure through how satisfied are you with your brand, from not satisfied at all, 1 to 6 completely satisfied, and recommendation probability we measure how likely is it that you recommend brand X on a scale from 1 not likely at all to 6 very likely. And we know we have content validity. That is a precondition to even check for criterion validity. Now we know in theory this relationship exists. Now we measure this. In this case, we'll probably apply a regression analysis. In our data, we find the same relationship. We find, yes, in our data, there is a positive impact of brand satisfaction on recommendation probability. So we measured what we know in theory. Happy days, criterion validity is high. The idea is, if it was low, then we must have measured something else if we can't find this relationship in our data. Here again, criterion validity, I need to be precise. Testing criterion validity in a normal applied sciences project, you would normally not test criterion validity. This is what you use when you develop, refine, and validate a measurement instrument. Then you must check, virtually always, you must check for criterion validity. But you wouldn't do this in a normal applied sciences research project. Finally, let's come to internal, external, and statistical validity. Internal validity refers to the aspect that the variation of a dependent variable is only caused by the variation of one or more independent variables. One can say with the example, if in our measurement, in our analysis, only advertising influences brand awareness, and we have a high internal validity, as we could establish advertising influences brand awareness. But if there are other factors we possibly do not measure, it's not just our advertising, but it's also sponsoring, public relations, and we want to look at the effect of advertising on brand awareness, we cannot say that only the variation, the change of advertising, was affecting the change in brand awareness. There might be other influences. So if we can determine that only our examined factors have an influence on a dependent variable, then high internal validity. If there are other influences, other factors, other independent variables that we did not measure, our internal validity is low. External validity refers to the generalization of results with regard to other persons, areas, times, context, etc. So for instance, we've measured work satisfaction in company XY. And then a high external validity would be given if we can generalize our findings to other employees, other companies, other countries, and so forth. Finally, statistical validity just refers to the adequacy of the statistical analysis and, of course, using the analysis correctly in their application. That was the quality criteria of quantitative research. The next lecture is about research designs, and I will explain experimental, longitudinal, and cross-sectional designs against the backdrop of what relationships can constructs of variables have in general. Until then, I wish you all the best, and it is bye-bye for now.